Alright, so what goes here? 2 equals log. Alright, good. What goes here? If it's 10, I don't have to write safe. I'm going to save some ink. Alright, what about this one? What about that one? Alright. Here? And here? Say that again? Oh, 2 to the 8. Okay. Yeah. Alright, I'll take it. What about this one? Oh, wait. X equals... And that one's done. Alright, great. Easy stuff, right? Okay, so remember, when you are evaluating a logarithm, you're figuring out the exponent, basically, that got you that number. Okay? I don't think we did this yesterday. But a logarithmic equation is an equation that contains a logarithm. Alright, now we're going to try to recognize some numbers. Okay, so they've given us 3 numbers. And we need to try to arrange them somehow that we create a true statement or a logarithm. Okay? Like this, 49, 2, and 7. How do those numbers relate to each other? I think I said 42 is 49. Alright, so what would that look like as a logarithm? Alright. How to do the other 3? What about this one? What would this look like as a logarithm? You got it right? Good. How about this one? Alright, what about this one? Excellent. Very good. Yeah. Let's just shut it down and take a test. Right now.
Yeah, I can put the test. Let's do it right now.
Yeah. Alright, so it is really important to be able to recognize this relationship between these 3 numbers, because a lot of things with logarithms, a lot of the problems with logarithms can be worked out without a calculator. If you can just recognize that relationship. If you can just say, like, if this were missing, and you go, well, that's really like 4 to what power equals 4? The only power that you could take it to equal the exact same thing would be 1. So you wouldn't need a calculator up then. You could just, use your head. Same thing for like this one. If that was missing, you would go, well, if that's the base of 7 and it's 49, that means I had to square it to get there. So you wouldn't need a calculator. You should be able to recognize those relationships between the numbers. And you've done a really good job, because there's nothing there to tell you what's what, and you figured out where everything went. So that's really good. That's really good. So let's look at the 3 things missing. Come on now. That was a big circle. So, if you have an exponential equation that you need to solve, you change it to a logarithm to figure it out. If you have a logarithm that you need to solve, you change it to an exponent to figure it out because they're inverses. One undoes the other. Like if you have a division problem, you multiply to solve it. If you have a subtraction equation, you add to solve it. If you have a logarithm, you change it to an exponent to solve it. Okay? So, and these are the three things that could be missing, basically. So they're showing you three different examples of what could be missing. It doesn't matter what's not known, you can figure it out. Okay? Alright? So, I don't want to do this. I'm going to skip some stuff. I want to go for solving right now. I'm going to do a couple of these together. What page is this? Page 14? Okay. So let's change this one around. On A, what would this look like as an exponent? Equals 64. I bet you know what power 8 has to be taken to equal 64, right? 2, right. 8 to the n is the same thing as 8 squared. See? If 8, those are, so n has to be 2. Pretty easy, right? Yeah? Yeah? Okay. I want you to try those. They get a little bit tougher, but try the remaining 5 problems. For B, how would this look? What would that be? N to the negative 2 equals 1 over 16, right? Okay. So I have to take something to a negative 2 power to get to 1/16. Is that what that's telling me? What happens when it's a negative? Right, it becomes a fraction. Is there anything here that I could maybe make it look like a square? If something was squared, it says over there. Is anything squared to make 16? 4 is. So n to the negative 2 equals 1 over 4 squared. Except that's a negative 2. So something was taken to the negative 2 power. So maybe if I did this. Is that a true statement? What's 4 to the negative 2? 1/16. So what does n have to equal? 4, right. So notice again, you don't really need a calculator right now as long as you can recognize the relationships these numbers have. They have some sort of relationship to each other. Over here, what about C? Right here. What's that going to look like? To the n equals 64. Okay. 1/2 to the n. I probably should put this on another page. 64 is a power of 2. Does anybody know what power of 2 64 is? What is it? 8? I don't think it's 8. Hang on. Because I think 8 is like this, like 512 or something. I think it's 6. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. So I could rewrite this. Okay. So I think it's going to be somewhere with 6. But what's the difference between these two numbers right here? This is a 1/2 and this is a 2. could I do something with this to make it look like a 1/2? Just by messing with the exponent? Make it a negative, because what happens when it's a negative? It goes to the bottom. So I could say 1/2 n equals 1/2 -6. So what does that mean that n has to equal? -6. And again, I don't need a calculator right there. I just need to be able to recognize the relationship in the number. We're going to get to some where you actually have to use a calculator, there's no relationship. But right now, you can just recognize the relationship. Does anybody need a form to check out a calculator, by the way, before we get to those? So I need 3, 4 forms, 5, 6. Okay, let me write that down. You might have to come back after the first period. Alright, let's look at the next one. Alright, what is this one going to look like? Oh, that one's easy. Let's just do 1 over 1, 2, 3 equals n. That one's just new math. Alright, let's look at E. What is E going to look like? N, 2/3. Okay, so I need to somehow get this related to that 2/3, because I know that it's N. I'm not going to mess with that one too much. What can I do? Is there anything I can do to 49 to make it more useful as far as exponents go? Make it 7 squared. Okay. Is there another way to write a cube root of 7 squared? So n to the 2/3 equals 7 to the 2/3. Well, if n to the 2/3 is the same thing as 7 to the 2/3, what does n have to be? 7. Is that a 9? Okay. So let's write this one out. 9 to the n equals 27. Alright. Probably going to have to do a couple things to this one. Because I can't make 27 with what 9. What can I make 27 do? It can be what to the what? 3 to the 3rd. And 9 can be 3 to the what? 2nd. Alright, so if 3 to the 2n equals 3 to the 3rd, then 2n has to equal what? 3, which means n equals 3/2. Alright, so does everyone see how that works? Yeah? Okay. Oh, one's good. Now, I will tell you this. As far as working with the logarithms like these, there is no, like, steps to follow. There's no process that I can say, do this, then do this, then do this. We can change it to an exponent, And then we can do nothing but try to find those relationships, how they go together, okay? You have to reason through it. Yes, you have to think and reason and try and get your thoughts together to figure out how this can match with this, how they can be the same, so I can see where they're equal. You have to do that. There is nothing that can just, oh, we'll put in your calculator and plus this and plus this. No, you have to reason through it. You have to reason through it, okay? You have to use your brain and your thought process and think about it. And some of you, it's going to hurt, okay? It will, because here's the thing. You know how like when you haven't been to the gym for 6 months and then you go to the gym and the next day you're like this? That's what's happening to your brain. You haven't used it in 6 months because everything's been so easy. Do this, follow that step, do this, follow that step, type it in your calculator, and we're done. Okay? This actually uses your brain. So tomorrow you may walk in and like your brain be all swelled up. Okay? And like you can't even hold your head up. You'll be walking in like this. I can't do it, Harper. I can't do it. Because you're going to have to use your brain. And it will hurt some of you. Okay? Yes, it will. You'll be fine though. You'll live through it. It's good for you. Alright, let's just estimate a few of these. Right here. Estimating logarithms. Alright, what page is this? 816. Alright, so up to this point, the logarithms have been like nice, pretty numbers. And this is where we start introducing numbers that aren't so pretty. Okay? Yeah, they're not so pretty. So logarithms of base 2. What's this number? Hint, it's like above it on the number line. 2, right? Because 2 squared gives me 4. So that's 2. What's this number right here? -1, because if I want to turn 2 into 1/2, I take it to the 1/2 power. Okay, so I've got -1. What would fall between here? Is there any way to get 0 as an answer? Could I get 1 as an answer? How? The exponent would be 0. So if I do, what would that look like as a log? Log base 2. Yeah. Okay. See what I'm saying? Alright. Let me ask you this. Let me ask you this. Place these twos on there. Mine can't do. Okay, do these. Do those. Where would those go? Where do you think those would go on this number? Okay, so this is where I'm going to put log base 2 of 1. Okay, that's how I'm going to, I can't, alright, what about this one? -2. Okay, so this is going to be, alright, and what about this one? So if I needed to find, looking at that number line, if I needed to find log base 2 of 1.5, that's basically log base 2 of 3 halves. So you're taking the square root of 2 and you're cubing it. You may know what the square root of 2 is right off the top of your head? Yeah, no, right? But if I wanted to know log base 2 of 1 half, 1.5, 1.5, do you know what two numbers it's going to fall between? Hang on. 1.5 is going to be somewhere between these two numbers. Okay. So, yeah, this is what we're going to start doing, and this is when you're going to need a calculator. Because up until this point, we've done these nice pretty ones that you can look at it and find that relationship. But when we start doing these hideous, ugly ones, not so much. Yeah. Okay. Alright, look at the pages that we tore out.